next speaker is Jerome Woody. We'd like to thank him for taking his time to travel such great distance from his home a block away from here to the conference center. And yeah, while all of you are getting bagels, he just woke up and came straight to the stage. He's a senior front-end engineer for Discogs, and he's here. Oh yeah, we also have one person who works there. And he's here to share with you about Vaporwave. Oh, I mean LLM chats. Vaporwave is for after party. Yeah, it's Jerome Woody.
Sorry, I'm trying to get this to work. It was working so fine like a half hour ago. Something happened. Yeah, thank you so much. So yes, my name is Jerome Woody. I am a senior front-end developer at Discogs, the best music site on the planet. But I am not here to talk about music. Maybe next year, if you guys are good. What I am here to talk about is television shows, including my favorite show of the 2010s, Westworld. Yes, thank you. Oh man, can we just beg for a new season? Somewhere. Just saying. So, in Westworld, one of the concepts in the show is what's known as analysis mode, right? And in the show, the hosts, the synthetic people who populate the futuristic theme park, can go into what's known as analysis mode, a state where the host can sort of disassociate themselves from their personas and go into a state of deep introspection, right? It is from this state that park employees can query the host and get a picture of what their thinking processes are, right? So, like many of you in the audience, large language models have been creeping into my workflow since late 2022, right? And today it's become one of the premier or one of the top ways that I analyze and transform information. Now, I'm a web developer by trade, so most of the time I'm using large language models and chatbots to generate code or debug code for whatever project I'm working on, right? And because it is code, you know, if I want to test it out, I can always throw it into an interpreter or a compiler, run it. And if it runs, and it runs as expected, great. But if it doesn't run the way I want it to run, I would either have to reevaluate the way I interact with the chatbot or have to rethink my whole methodology entirely, right? However, I also use chatbots to ask questions about various subjects outside the realm of computers, right? Sometimes I want to know about an argument of something or get some facts about a concept that I'm not familiar with. These types of outputs you cannot easily put into a logic checker. So it is at this part of my interaction with large language models that I wonder, can I have my own analysis mode? And I think I found a solution to this. And the solution comes from a very personal place in my life, my library science education. Meet Dr. Michael Eisenberg. Mike was a professor at Syracuse University, and he, along with a librarian called Bob Berkowitz, created what's known as the Big Six process model for information-based problem solving, back in good old 1988. This is an information literacy model based to teach anyone how to do effective research. I met Mike when I was a student at Syracuse, go Cuse, back in the late 90s, and he went on to become the founding dean of the information school at the University of Washington. Go Dogs. All right, so what you're seeing now is the Big Six. And the Big Six is follows, and I'm gonna have to look this up because it's a lot. Task definition, define the problem and identify information need. Information seeking strategies, determine all possible sources and select the best ones. Location and access, find the sources of information within them. Use of information, read, listen, view, and extract relevant information from sources. Synthesis, organize information into multiple sources to create a product or answer. And finally, evaluation. Judge the product's effectiveness and the process's efficacy. Anyone can use these steps to do effective research. So I thought, what would happen if these steps were done by a chatbot? Went back, there we go. Okay. The Big Six process model is one of the most popular tools for teaching information literacy worldwide, and it has been for decades. It has been taught in classrooms and in libraries throughout the world. Many papers and explainers have been written about it, with most available on the open web, which was, by many large language models, trained on, right? Because of this training, the concept of the Big Six is included in their knowledge base and can be inferred upon by just using a text prompt. Through experimentation, I found that combining a reference and just a reference to the Big Six with a task and a text prompt dramatically changes the output and organizes it based on the Big Six model. This can be done in two ways. In the initial prompt, which I call blueprinting, and as a follow-up prompt, which I call reflective analysis. Although reflective analysis comes closest to what I was thinking while watching Westworld, I believe that it's through blueprinting that using the Big Six can lead to higher quality output and possibly fewer hallucinations. All right, so let's see what I'm talking about here. Okay. In this video, you see me applying blueprinting to a prompt in ChatGPT. The prompt's main task is to have ChatGPT generate an explanation for the factors that led to the 100 Years' War. Notice that I only had to refer to the Big Six in order for the output to be organized into the 6 steps. I call this technique blueprinting because, along with the answer, the LLM generates a blueprint to help users find the answers themselves. The LLM's answers are still there, spread out in step 4 and step 5 of the process. This technique does not just apply to ChatGPT. Any LLM using a text prompt interface can have this technique applied. Here you see me applying the blueprint technique to Anthropic's Claude chatbot. I asked it to give me a history of the neighborhood that we are all currently in, First Hill. Whoop. That one got excited. Here I show an example of reflective analysis using Gemini. Oh, Gemini. First, I use a traditional zero-shot prompt asking for an explanation over the ontological debate regarding what came first, process or entity. And we got information science people here. I know you guys are vibrating right now, because that is heavy stuff, right? Once Gemini creates its output, I give it a follow-up prompt, asking it to consider the last output using the Big Six model. It then takes its previous output and breaks it up into the 6 steps. It's like giving a student a homework assignment. So, how is any of this possible, right? I have a hypothesis, and I hypothesize that by having to process a model like the Big Six, contextually, LLMs are forced to be less creative because not only would it have to infer the main task in the text prompt, but also token weight spaces related to quality control concepts, like breaking down tasks, considering sources, and evaluating its own output. So I have a name for this hypothesis. I'm calling it the Ariadne hypothesis, after the Greek goddess of mazes and labyrinths, but there's also a character in the movie Inception, played by Elliot Page, who's also called Ariadne. I don't know if anyone noticed that. But yeah, that's true. They named her after the goddess of mazes, right? Like that character who builds mazes to control a target's projections, blueprinting creates a maze of context in which to control hallucinations. I sincerely stress this. This is just a hypothesis. It has yet to be scientifically proven. It's just a hypothesis. Research related to using prompt-based techniques to clamp down on hallucinations has been done. Researchers at Tencent have found that if you prompt an LLM to give both the right and wrong answer to a question, a question to the output, which is also called contrast prompting, the chances that the right answer will be right increases significantly. Researchers have also observed increased performance in symbolic reasoning and arithmetic. Although this is not directly linked to what I'm proposing, the research on contrast prompting seems to prove that using reflective-based contexting can improve output quality. All right. To wrap up, I believe that everyday users, including everyone in this audience, using LLM chatbots can use the Big Six in the techniques that I have described to simply, in a simple way, to imbue some level of quality control and transparency into your text prompts. Blueprinting may or may not lead to less erroneous output. I don't know. I really don't know. It's just a hypothesis. But at least you will have a printable blueprint to use to determine that yourself. To academics in the audience, and I hope there's a few, I urge you to look into my hypothesis and determine if I'm onto anything here. To AI developers, which I'm sure are in the audience, the Big Six can be something that can help train models to reason better, or as a structural mechanism that you can plug into the model's input layer to help guide token computation. Either way, I firmly believe the key to making LLMs generate more accurate output is by serving it prompts with a side of library science. Thank you. And on the slide here, on the left, is a link to the actual Tencent paper about contrast prompting. And on the right is a GPT that I have configured, with Big 6 context built into it. So you don't even have to use the substring, use Big 6, just ask it any question. It will know to use that Big 6 model in its output. So go ahead, go on there. Obviously, ChatGPT Plus is required, but as soon as other type systems come out, I'll make versions of that. I know like Gemini's coming out with a GEMS system, so I'll probably do that as well. But for now, there it is, and that's my presentation. So thank you so much.